Another kind of problem that we'll need to be able to solve from points on a circle and a central angle is this. Suppose we know that the point of intersection. Are we able to not only determine the angle, but are we able to determine all of the trigonometric functions from this? Well, the answer, of course, is yes, and we can get this, of course, from our calculator. We get a decimal approximation, but we can also compute these exactly. So let me show you both techniques. The first one is this. If we just wanted to get a decimal approximation, we've learned already that the radius of this circle is going to be the square root of the sum of the squares of the x and y coordinates. So we've got 5 squared plus 3 squared. Take the square root of that sum, and that'll get you the radius of this circle. So we have 25 and 9 inside of that square root. Sum those up, we get 34. And that does not reduce to anything nice. 34 is 2 times 17, and both of those are prime. So root 34 is the radius of our circle. So that tells me immediately that the sine of theta, for instance, is the opposite. That's the height, 3, over the hypotenuse, root 34. And therefore, theta is the inverse sine of 3 over root 34. And if you want an exact value, that's a perfectly good one right there. Now, our calculator can convert this to a acute angle quite easily. I can find the inverse sine of 3 divided by root 34, 4, not 2. And we get about just a little bit short of 31 degrees. So this is approximately 30.9638. Okay, now once we have the angle, of course, we can get any of the trig functions by computing the sine and cosine, then taking reciprocals or ratios. So from this, you could get the cosine of theta without reference to our picture here, because you got the angle sitting on your screen, right? So you could say, what's the cosine of that? Well, it would be the cosine of whatever angle we had before, and we find out there's a decimal approximation to the cosine. However, I think a little bit better way is to work from the picture and say, well, the cosine is the adjacent side, 5, over the hypotenuse, root 34. And then if we wanted to get a decimal approximation, it should come out to be effectively exactly what's on the screen here. Let's give it a try. 5 divided by square root of 34. And sure enough, it agrees with the previous value. The thing is that you can get the decimal approximation from the exact value. The other way around is not true. Just because I have that sitting on my screen doesn't mean that I can readily guess what the exact form is of the angle. Now, once I have the sine and cosine done, I'm good to go on all the rest. For instance, what is the tangent of theta? Well, we know that the tangent of theta is equal to the sine of theta over the cosine of theta, or another way of looking at it, it is the opposite over the adjacent. The opposite side is 3, the adjacent side is 5, that's 3/5, or 0.6 if you want it as a decimal. Of course, we could have gotten it from this. If you take this, divide by this, the over root 34 part will cancel out, and you'll get 3/5. What about the cotangent? The cotangent is the reciprocal of the tangent, 5/3. What about the secant? Well, the secant is the reciprocal of the cosine, root 34 over 5. And what about the cosecant? Well, it's the reciprocal of the sine. And the sine is 3 over root 34, so the cosecant is root 34 over 3. So the key here is to get the sine and the cosine, and then to know these ratios. The tangent, sine over cosine, cotangent, cosine over sine, secant, 1 over cosine, cosecant, 1 over sine. Those should be committed to memory because you use them so frequently. So what if you now had an angle that's way around over here, so that we actually got some negatives in our x and y coordinates? In this particular case, we're in the first, second, third quadrant, and that gives us both a negative x and a y. So what is the sine, what's the cosine, etc.? Well, the sine of theta is, as usual, it's going to be the y-coordinate over the radius of the circle. The y-coordinate is -5, and the radius of the circle is something we need to figure out. Well, the radius of the circle is the square root of x squared plus y squared. X squared minus 2 squared is 4. Minus 5 squared is 25. 25 and 4 make 29, root 29, and 29 is a prime number. We can't factor that. So over root 29. What's the cosine of theta? Well, it's the x-coordinate minus 2 over the radius, root 29, and we've got that one done. What's the tangent of theta? Well, the tangent of theta is the sine over the cosine, and we'll have -5 over root 29 divided by -2 over root 29. Now you can put the over root 29 in here if you want, but they're just going to cancel out, right? Because you multiply top and bottom by root 29, and you're left with 5/2, and that's 2.5. So the tangent is 2.5, and the other 3 we get by taking reciprocals. The cotangent of theta is 2/5. The secant of theta, reciprocal of cosine, root 29 over 2, and that's negative. And the cosecant of theta is root 29 over 5, and that likewise is negative. So once we know the sine and the cosine, the other 4 fall out by taking ratios of what we already have, and the positive and negative figure into these in a way that you could predict from whether the x and y coordinates are positive or negative. Sine is always y over radius. Cosine is always x over the radius, and that will get you started on these, and taking ratios and reciprocals takes care of everything else.